Hey guys, this is Chris from the University of Bayreuth here in Germany. Thanks for watching and helping us evaluate our tool, which is called RDB2Log. Our tool helps users generate quality-informed event logs from relational data such as SQL databases. This project is a joint effort of the Queensland University of Technology in Brisbane, Australia, and the Universities of Augsburg and Bayreuth here in Germany. In the next couple minutes, I'll talk to you about our theoretical approach and the software prototype that we've implemented and tested in various settings. If you have any questions, feel free to contact me via the email address given to you with this video. First, I'll tell you a bit about our motivation for doing this research project, as well as some of our theoretical background on data quality and event log generation from relational data, and our research method, of course. And afterwards, I'll explain to you what kind of evaluation we're doing at the moment. Afterwards, I'd like to show you our prototype in a screencast video, and we'll have a sample data set that we can use with the prototype, and we'll show you that it actually does quite an amazing job at generating event logs from it. Afterwards, if you would be so kind, it would be greatly appreciated if you could help us and fill out the survey, whose link was also given to you with this video. As most of you guys will definitely know, process mining is a way of discovering, monitoring, or improving real processes by extracting knowledge from so-called event logs. Those event logs are basically flat data structures that show us a list of activities that have been executed at a given time in a context such as a business. As in any kind of data mining application, the part of extracting and preparing data for the actual mining is one of the most integral parts. Studies show that about 60% of the effort in any kind of data mining application are allocated to the preparation phase of the data. The term garbage in, garbage out has been around for decades, and it's quite famous in the data scientist community. What it basically says is that if you input low-quality data into any kind of data mining application, what you'll receive as output, as results, will be of equally low quality, or will be at least at risk of being of equally low quality. So what you'd expect is that research in the area of process mining will ensure that there's ways of creating and preparing event logs in such a way that they're of high quality enough for process mining to create sufficiently high quality results. However, this is apparently not the case, as the only thing that literature actually describes are maturity levels for event logs that don't actually help users in creating those event logs in a high quality way. Imagine, if you will, that you'd like to conduct process mining on the data procured to you by a hospital ICU unit. If you look at this image, it's a data schema of an actual IT system of a hospital ICU unit in Boston. It was published by the MIT for research purposes. If you have a closer look at it, you'll see that even though it maybe doesn't have as many tables as one might expect from a typical business IT system, it's still quite confusing to look at if you don't have any specific domain knowledge. So without any kind of metadata, you'd be pretty lost in the beginning if you'd like to extract an event log from this. You'd have to be looking for primary keys that could be used as case IDs. You'd also have to be looking for activity names and timestamps. You'd also, first of all, have to understand the data and what it's actually describing. So what's in this data set is treatments and medication prescriptions and allocation of beds for patients and their respective doctors and nurses and all that stuff that you'd expect to be recorded in a hospital. What you want to get out of a relational database like the one I've shown you is an event log that looks a bit like this one. It's a flat table structure, as I've told you already, and it has a couple of integral parts that are essential for an event log, as you probably know. There's the case ID, which is basically the denominator of the process instance. And for every process instance, there's a lot of activities. In this case, they're called event IDs. For a patient, which is the process instance in this case, there could be activities such as the admission to the hospital, lab events such as blood work, research, there could be ICU stays, there could be transfers, and at the end there hopefully will be a discharge. All those activities have at least one timestamp. They could have multiple timestamps, such as starting times and end times. And there could also be a lot of additional data, such as, in this case, resources, nurses or doctors that conduct treatments or put the data into the IT system. There could also be a lot of other additional data. I'm thinking about actual diagnoses, prescriptions, whatever you can think of that informs us even more about the process instance or about the activities being performed. So what you can probably see by now is that the way from here, from a process-related relational data set, such as the hospital IT system, to here, to the event log side of it, is not as easy as it's supposed to be. So although you might think that, well, the process data, it's all in here, the extraction should be quite simple. It's not, because if you don't know about what kind of data it is, if you don't have any domain knowledge or metadata on the data set that explains to you if the quality is high enough for process mining, or what kind of data attributes are in the data set, you're going to have a hard time at extracting an event log from this. So we've come up with a way of facilitating this process from relational data to event log. We call it RDB2Log, which stands for Relational Database to Event Log, and it supports users in extracting those event logs in a high quality from relational databases. Normally, data quality assessment is something that is done ex post, so we create an event log and then we look at it and we say, well, the quality is actually not as bad as we thought, or it's worse than we thought, and we can't actually do anything with it. In our approach, we want to put the data quality assessment right where it's supposed to be in the extraction process. So we look at the process-related relational data set, and we evaluate it regarding data quality, and we can say, well, this data set is actually worth considering for process mining, or at least a couple of data attributes are. And in parallel, we look at the database network, at the relationships between keys and tables, so that we can provide users with insights into the database and how we could possibly extract logs from it. At the end of this process, we would be able to guide the user in assigning roles to the data attributes that tell our tool that, well, this data attribute is a case ID, this data attribute is a timestamp which belongs to the activities in another data attribute, and all of this can not only be done in one database table, but overall database tables that are linked by key constraints, such as it is in SQL databases. At the end of our approach, what you want to do is only click a button and it produces an event log that is in the right format, such as the XES format that is used by most process mining tools such as Disco or ProM. So I've already talked a lot about data quality in the last couple of minutes. What actually is it? Data quality is mostly seen as a dimensional concept in current literature on the topic. Dimensional concept means that, well, quality is not measurable as something one-dimensional, but which has to be evaluated along multiple dimensions. Those dimensions could be, for example, accuracy or completeness or precision. Those words probably mean something to you in a way of quality. So if you look at data, you could probably say, well, this timestamp is kind of precise. It's measured in milliseconds, so yeah, that's kind of a precise timestamp. Or this column is quite populated, there are no missing values, so this is a complete column. But apart from that, those terms are probably quite abstract to you. So if we want to measure those dimensions, in the end we need a couple of metrics, like metrics, hard-coded metrics that could actually calculate a value of quality, of accuracy, of completeness, of precision on a given data attribute. So first of all, we've selected, those are the red ones, first of all we've selected 12 quality dimensions that are probably relevant to process mining and that are also measurable with metrics that I'll show you in a moment. Those 12 quality dimensions are accuracy, currency, completeness, consistency, privacy, precision, integrity, objectivity, conciseness, sufficiency, uniqueness, and informativeness, which is a weird word, I know. For the purpose of measuring those quality dimensions, as I've already mentioned, we've extracted a list of about 25 metrics from recent literature. Those include quite basic metrics such as the ratio or count of duplicate or missing values in a column, but also more sophisticated ones such as the calculation of outliers on the basis of statistical principles from a given data column, or also the calculation of a precision value for numeric or timestamp columns. I've already explained that, for example, a timestamp that is recorded on a millisecond basis is probably more precise than a timestamp that is only calculated up to the day or hour of an event that has happened. What you can see here is an impact matrix that shows us if a metric informs a given data quality dimension. In our concept, a metric can inform one or more than one data quality dimensions, but a data quality dimension can also be informed by more than one metric, so it's an end-to-end relationship. By now you might have realized that basic metrics such as the ratio of missing values in the data column is only more or less informative. So if we actually want to know something about the suitability of a data set for process mining, we need to understand if the values that are in the database are actually true or correct or relating to the real world in any kind of way. For metrics such as these that tell us something about, for example, the dimension accuracy, we need input in the form of domain knowledge. So we need to understand if the values in a data column are actually relating to the real world. For this, there are several types of ways to get input in the way of domain knowledge. We've categorized it depending on who is inputting those values. So is it something like metadata or ontologies that exist as a technological concept, or is it a domain expert who knows something in a subjective kind of way and we need to extract it from him, for example. Also, there are several moments of input, so we can input this kind of data before the analysis of the data quality, but also afterwards. So we can say, after calculating some kind of data quality metric, we give feedback on that and can say, is this value correct? Do you think this is correct? Or something like this. For our prototype and for keeping it simple enough, and because it's always hard to get domain knowledge such as this, we've selected what I've marked in the red square here as the only thing that we've implemented in the prototype so far. Mostly we rely on metadata that tells us something about what the data is about, what, for example, a normal interval of values in a data column should be, so that we can compare this with the data that is actually in the database. So in the end, after we've calculated all the data quality metrics and populated the dimension values, we can create something we call conditions. So conditions tell us something about the suitability of the given data column as content for our process log. For example, if we want to use a column as case ID, we need it to be a unique key or a primary key in any kind of parent table, and there needs to be at least one foreign key that relates to this kind of key so that we can get information from different child tables, not only the parent table. We see process instances as table rows having one-to-n relationships to its event events rows. So we need to have a table where the case ID key is a unique or primary key. More than that, we need our key to be some kind of numeric. It could also be a string or a date time or whatever, but numerics are most suitable as a case ID. We also have the case ID to have an accuracy value higher than a given threshold or an objectivity value higher than a given threshold. Those conditions are more than are shown here on this slide. We also define conditions for any other event log roles. So for example, the timestamps and the transition values and so on. We want to have, of course, a data type for timestamps that is an SQL datetime or a datetime2. It could also be any other kind of value that represents a date or a time value. We want timestamps to be quite current. We want them to be quite precise, so it's best if they record on a millisecond basis, and of course they should be unique as well, because timestamps that are to the millisecond the same show us that something might be wrong in the recording of these timestamps. After we've done that, we'd like to click this infamous button and create the event log. But how does that actually happen? We've identified several kind of ways that events can be represented in a relational data set. I'll show you a couple of examples here, but those are not exhaustive. We've already identified several more ways of how events can be represented in the database. This is just supposed to be exemplary. Imagine, for example, a line in a database table like the one on the top here. Here we have an ID that in our hospital example is the ID of a patient. It's in this column, which is called admissions ID. And for this patient, we have timestamp columns for something that has happened at a given time. In this case, we have several of them in one table row. We have an admission time. A patient is admitted to the hospital at a given time, and he's discharged at another given time. Fortunately, in this case, he didn't die during his time in the hospital. And we see that in the name of the data columns, we can identify what has happened. So in this data column, we see discharge time or admissions time in this one, shows us that at this given timestamp, the admission has happened or the discharge has happened. So we will use these column names as our activity names. So we know that the patient with admissions ID 1234567 was admitted on August 7th, 2025. This is just exemplary, and he was discharged on September 22nd in the same year. Another way of extracting the event is shown in the second example. The record shows a patient transfer from one unit to another within one hospital. And here the name of the activity is not the column name of the timestamp, but rather the content of another cell in the same row. So for this activity, we know that the given patient was transferred on the 1st of September 2025 to surgery from one medical unit that we don't know, but we want to know where he was transferred because this is the activity and it is saved in another cell of the same row. Another still more complicated way of representing events is shown in the third example. This table represents prescriptions to a patient, and there can be several rows prescribing different drugs to one patient at a given time. So, for example, look at this patient again. It's still the 1234567 and on 6th of September 2025 he was prescribed a bunch of drugs. I don't know what he's got, and but we do not want to know about what he was prescribed. We just want to know that on this given date he got a prescription for one or more drugs, and we again will use this column name, which is called prescription, as the activity name, and this timestamp, which is the same for all rows, as our timestamp of the given activity. Remember, like I said, this is only an exemplary list of possible event constructors, as we call them, and many more are possible. So thanks for listening to me talking 20 minutes about our theoretical approach, and now I'd like to show you quite quickly what our prototype can do for now. Hey guys, thanks for still watching, we appreciate it. What I want to do now is show you our software prototype of the approach. So to start at the beginning, I'll just execute the tool and then I'll connect to the database where our source data is in. I've hosted it on my local system, so I'll just put in the data here. And I'll not execute the data quality assessment on the bottom here because I've already done that and it takes a couple minutes. What we can see here is the main window of our prototype. First of all, the database that we've now loaded into it is the same one that I've shown you earlier in the slides. It's from the Boston ICU unit. It's hospital records. And what we can look at is first we have a drop-down box here where we can see all the tables of the dataset that have a primary key or a unique key, and which can act as our parent table when we want to create our log. I'll explain more of that in a minute. When selecting a table, we get all the tables here in tabs that have referencing foreign keys to keys that are in our main parent table. We will call them child tables. For every table that we see here, we get a short summary up here regarding all the primary and unique keys, the row count, and number of timestamps, which of course is important for event logs. And in the main part of the window, we get a list of all the columns that are in the data table, along with its data types and, most important, all the data quality dimensions and its valuation on the right side. So we can see that, for example, this admissions ID here has an accuracy of 50%, a sufficiency of 60%, and so on. Now the first thing that we need to do when we want to create an event log is select our case ID. This means that we have to select what kind of process we want to look at. In our example here, we'd like to look at the process that a patient goes through when he enters the hospital until he leaves. So we'll select this admissions ID here, which is the ID that a patient is given at the beginning of his stay and stays with him during the entire time of his stay. So we'll select this as case ID. We can do this in this column event role here. And as soon as we do that, we get color-coded values here that shows something about the suitability of this column as a case ID. So it is an integer type, data type, so this is quite a good choice for a case ID. But we can see a couple red values here. For example, we have accuracy values of 50% and sufficiency values of 60%. This means that the metrics that were calculated to give us an indication of the data quality have values that are not high enough for this column to act as a case ID. For example, the sufficiency here tells us something about how many rows there are in the table and how many case instances there are. So 60% is not really good enough for a whole process log that we want to analyze. However, the user can still decide to ignore these suggestions because that's all they are at the moment, and still go on with his choice for the admissions ID as case ID. The next thing that we need to do is select events for all those process instances. So for every case ID, we now have to select what kind of events have happened for every process instance. We'll start with this column admit time here, which is a column, a date time column depicting the time where a patient has entered the hospital and was admitted to the hospital. We'll use the role event, which basically says that, okay, use the content of the column as the timestamp and use the name of the column as the event name. So that's what we'll do. We'll put the transition to complete here because that's the only timestamp for this event that we have. And we can do the same thing for the discharge time and the death time here, if it happens, unfortunately. So now we already have the first three events characterized for our process. We can also add some more additional data to the processes. So it might be important to add, for example, the insurance information, the language of the patient, the religion or the marital status or whatever as a case data, so it gets allocated to the actual process instance that that is shown by the case ID here. We can see that for case data, the suggestions here are mostly green. We can also see that we get the same indication of sufficiency for our events that we have characterized, and unfortunately the column of death time is not complete, so we only have 31% of populated column cells. However, rationally that's a good thing, because only 31% of the people shown in this table have died during their stay. So now we actually have our first event log that we could export from our tool. If we deselect this checkbox, we can actually press our infamous button generate event log, and abracadabra, we have a finished XES file in the XES XML format, which we could already import into Disco or any other tool that accepts this format. But of course, this is only a really small kind of event log. So what we want to do is add more events to the process instances, of course. But unfortunately, there's not much else to do here in this table. So what we can do next is go into the other tables, we called them child tables before, and see if we can add more events that also relate to this admissions ID here. So let's go, for example, into the table ICU stays. This table explains information about how long people have stayed in the ICU unit and when they have been transferred there and when they've been transferred back. And we see that they also have the admissions ID here as a foreign key. So it has already been selected by our prototype when we selected it in the admissions table. And what we can do now is select additional events here. So for example, we want to have the in time as an event as well, and the out time, the time exiting the ICU, as an event as well. So we can do that. But that's not all. Of course, we already also have to look at the data quality again. I'll skip this part a little bit to go faster. And let's, for example, have a look at the services table. So this time, we have a column here, a date time column, transfer time, but we want to have a little bit more information about this event. So this time we want to only select it as timestamp. This means that the value of this column, of this cell, the timestamp value is used as the timestamp, but we need another name. We won't use the column name as event name, but this time we want to use this current service as the event name for our event. So what we do is select it as activity here, and then we have to match those two together so that we know that this timestamp belongs to this event name. So we give them the same ID here, which means that we basically match them together, and a prototype recognizes this as this activity belongs to this timestamp. We also select the transition here, and we can deselect the box again, and again we can export a this time much bigger event log from our prototype. So let's have a look at Disco then and check if our exported event log is actually successful and insightful. We'll go into Disco, and I'll just open this mimic log that we've just created, and as you can see, we get a fully functioning event log that is displayed here in Disco. It starts off patients with an admission mostly, and it mostly ends with a discharge down here, sometimes with a death time. In the meantime, some people go in the ICU, then go back out, and they have some different procedures here that we put in the services table. And of course, we can zoom out a bit with the paths and see that they all go very different paths in this spaghetti process. But this quick example shows that our tool is actually already successfully exporting event logs from a source database, and this with just little work and little information on the part of the user. So it's actually working, and we're pretty confident that this is a thing that could be useful for process mining experts end users all around the world, especially for users or companies that know their data very well, but who are not really confident in manually exporting their own event logs, or people who want to have a first look at the data quality and then do some preliminary process mining. Yeah, we hope that this was informative for you, and we would very much appreciate it if you could take the survey that we sent you with this video, because your feedback would be invaluable for our research, for continuing research and publication. And if you have any questions or feedback or insights or additional information, feel free to contact me via the email address that was given to you with this video. Thanks for watching. Bye-bye.